But yeah, we're really excited to welcome you to this session, which we titled Step into the Future, Real-Time Shoe Identification with AI and Fabric. So we're going to dive into a fascinating project that blends artificial intelligence with real-time data processing to solve a challenge that surprisingly starts with something as simple as a shoe print. So at the heart of today's session, we'll be showcasing how we leveraged Fabric to build a solution that can identify detailed information about a shoe based solely on a photo of its sole. So I know what you guys are thinking. Two women talking about shoes, how cliche, right? But we're going to embrace this and we're going to go with it. So today's agenda, we're going to give you a bit of an introduction because I like to tell a story when I talk about data. I don't like just to show you the code or the demo. So we're going to start with a bit of an intro about why and how that works. And then we're going to move on to some user cases and how it is included and how it's used for those particular areas. And then we're going to go through the demo and show you the code. And we think we're even going to train it on a brand new pair of modeling shoes in this room today. So you guys can see it, and then we will finish off with some summary and questions. So yeah, when we were coming up with the idea for this demo, which actually it was all because we wanted a bit of a free trip to Stockholm. So we actually submitted this for Fabricon there, and we were selected and able to share it. So we were like, let's come up with a great idea. So we were sort of brainstorming, and like I said, I like to tell a story. So we decided that we'd pick something really, really relatable and go, let's face it, everybody wears shoes, right? And then we combined it with something that is equally quite captivating at the moment, and everybody seems to be watching all these documentaries about crime. And so I was like, perfect, shoes, murder, I love it. So let's go there. So we married the two concepts, and the idea of identifying shoes from crime scene prints was born. So we wanted to be able to showcase something that really got people thinking about how they could leverage the capabilities of Fabric and technology, and then what they could go away and build for themselves. And that's what we tried to do with this demo. And the underlying structure is basically, if you have a database of images and you have something that you want to find out from an image, it will work. So we started off with our demo, training it on cards, like literally a deck of cards. And from that, we were able to grow it to be able to go into the shoe printing model. So funny enough, it actually sparked a bit of traction from the few times that we've shown it in a few different use cases. We've had calls from police officers that have asked us to go through it in demo, and they've started thinking about it. And funny enough, the CTO of Telefonica Tech called me the other day, which is always quite nerve-wracking in the morning, like, okay, CTO wants to speak to me. He's like, I've got a gun. Like, excellent, right? That's even more worrying. And he was going, well, what I was thinking was, we have to register it, and we've got all these bullets, and they all, apparently when you shoot a gun, a bullet registers a print on it. And he's like, so can we use your demo for that? And I was like, yes, of course we could. So he's gone off and he's reaching out to people talking about guns, and I'm like, maybe don't word it with, I've got a gun. But the idea is you can see that once you see it, hopefully it can spark in something in you. If you guys are working with Fabric or working with clients or whatever, just think how you could use it and then go from there. So yes, let's move on to the next slide. So use cases, which is where we started with it. So in many criminal cases, shoe prints left at the scene can be a critical part of evidence. So however, traditionally, identifying a specific shoe from a print can be a long, complex and manual process to compare, because what they have to do is they have to compare the print to a database of the known shoe pattern. It can take days or even weeks and potentially slow down investigations. So in many cases, footwear evidence can lead to positive identification of which particular known shoe made that print. Footwear evidence can provide investigators with a certain amount of information that can assist them in locating a suspect. Most footwear evidence, when collected and preserved properly, can provide the type, make, description, approximate size, and the number of suspects. But it takes time, and a lot of time. And it can be found in nearly every single crime. So we started off and we go, right, let's have a look. Let's find some statistics. So we thought, let's have a look at how many crimes were solved by leaving a shoe print behind at a crime scene. And we asked it like, okay, so Nike Dunk, let's go with that. How many Nike Dunks shoe prints have been left at a scene, and we have been able to link it to the suspect? And literally it comes back with foot from the internet. Footwear impressions can be matched to specific brands, models, and sometimes even individual shoes, helping to link suspects to crimes. Nike, being one of the popular footwear brands, often appears in these cases. But precise statistics on how many times the specific model, like the Nike Dunk, has been evolved are not publicly documented. So that's helpful. So if we switch to the next slide, we'll go through what actually happens. So this is the exact process that happens today. So as you'll see, this one is left at a crime scene. So that's what they have. And then what they do is they move on to the next image, which is a cast. So they go and take a cast of the image. And after that, they have to wait for it to set, mold it, blah, blah, blah. And then they go and try and match it to the shoe. But that's a real manual process. And as I said before, it can take weeks, even months during a case. So we've actually, later on, I'll show you our demo. We've actually taken this one here and show you how long it would take for our demo to be able to highlight which make and model that would be. But actually, yes, sorry. So we then moved on to which particular criminal cases, any famous cases where shoe prints played a key role in saving the crime. And there are a few notable examples. So one particular one is the BTK killer. His name was Dennis Rader in the States. And during one of the early crime scenes, investigators actually found a partial shoe print from a rare model of an Adidas sneaker, which they linked to his movements in the house. But it wasn't enough to capture him initially. The print was a piece of the puzzle that helped them link to his crimes after the eventual capture in 2025. The real famous one in the UK is the Yorkshire Ripper. In the 70s, one of the critical, I can't even speak today, evidence was a distinctive shoe print left at a crime scene. And they were able to determine it belonged to a rare brand and size, helped narrowing down. And it took so much time that when they eventually had done it, he had gone on to kill several more people. But our process could have done that in seconds. And then the one that is on the next slide is probably a huge one I hope everybody's heard of, is the O.J. Simpson trial. So this one was really interesting because this was the bloody shoe print that was actually left at the crime. And they were identified coming from a pair of, I always pronounce them wrong because they're quite rare, Bruno Magli shoes. And the prints were used as evidence in the trial. They were not used as evidence in the trial due to time. And Simpson was even denying that he even had these shoes. And he later found a picture. And he was obviously famously acquitted in the criminal case, as we all know. But by the time they were actually linked this shoe print back to him, they actually had taken him to court for a civil case, which is where he did end up doing time. And this helped lead to that eviction. So to summarize it up, and I'll stop talking and we'll get to the demo. In criminal investigations, every minute counts. And that's where this technology can really shine. With AI-driven tool, law enforcement can make informed decisions faster. Instead of shifting through piles of data manually, they can rely on AI to enhance it. It can deliver precise results in real time, freeing them up to focus on crucial aspects of the investigation. Beyond speed and accuracy, this tool also allows investigators to gather more comprehensive evidence. For example, they can see whether the shoe in question has been involved in previous investigations or track patterns of shoe-related evidence across multiple crime scenes. In an age where data is everything, having this capability built into real-time AI solution is a game changer for law enforcement. Our solution takes a process that historically involved a lot of manual effort and makes it faster, smarter, and more reliable. And while we're using shoe prints as our entry point, this approach could extend to other forms of evidence as well. Excellent. So let's just tell you a little bit about the architecture that we used, because it's all in one place at the moment in the slide deck. So hopefully you guys have been working with Fabric, but for me, the way I describe Fabric to people is it's a collaborative tool for everybody. It's bringing together the groups of people who are often either siloed in their journey of using data or haven't even been able to use it at all, other than what maybe has been given to them. You know, the people that in telephone tech that we serve the data for, they don't always get to see the data themselves. They get the end point. So, but for me, it's a hub where we all get to work collaboratively and collectively to develop, design, and build data into insights. So, there was times when we were both doing lots of different areas, which wouldn't normally happen. So we used files and the internet to ingest our data because we needed to get a database of shoes and the makes and models. We needed to get the images of what they are, what the brands are. And we also have a bit where we talk about sizes. So we also needed to have a gauge of what people's shoe sizes potentially could be. So once we'd ingested it from there, which we did via notebooks, we then inserted it into the Lakehouse. And from there, we were able to write further notebooks for training, create experiments and machine learning models when we were happy. And then that goes back to the Lakehouse to be able to connect to a semantic model and your Power BI. So the reason I say Fabric brings everyone together is because you've got lots of different areas here that would be dealt with by, in theory, some different types of data engineers if you stick in your own lane, which none of us do because we all like to play. So up here with your machine learning level, that would predominantly be done by your data scientists. But down here with your ingestion and your pipelines and your data lake, that would probably be more done by your data engineering. And then you finally come over to your semantic model and your Power BI, which would normally be done by your Power BI users or your analysts. So using Fabric allows us all to work collectively and cross-apply our skills. There were times both me and myself and Rosie, even though we're data engineers, we're both working on the same notebook to create the experiments for our machine learning model. Yeah, so we're both working on the same bits at the same time. So yeah, that was pretty much the 5 bits. That summed up really well. So you can actually move to the demo. So obviously we haven't set it up. It takes when you start a cluster, it sometimes takes a bit of time. So we're just going to start the cluster again. Better? Oh yes, yes. So we're just going to start the cluster and then we'll switch back to this. We're done with time and we'll show you. Okay, so as I said, so actually, can we switch straight to either the O.J. Simpson image or the one from Friday? So as you can see, I uploaded the image. I will ask you to remember that it's a demo, so we actually only trained it on these brands across the bottom. So I wasn't going to search for Bruno Magli shoes for one image. We did Vans, Converse, Adidas, Lacoste, Skechers, Nike, and Timberland. And then each of those have a few different models within that brand where possible. You know, Vans only really have one model, classic. And actually, that's, to be fair, I'm pretty happy with that solution when it came out. When you're doing your experiment, we'll show you later the accuracy and the loss that you can see within it. But as we said, so we've got statistics here. So from our model is a 99% chance that it is a Vans, which is pretty high. And there is a 79% chance that out of that, it's going to be a Vans Classic. So if we drop down, because we actually, when we were in Stockholm, we actually asked one of the audience to click reverse and upload it straight there, in the room. And it is that one, I see the room. And literally he was sat there. So he had some weird shoes, didn't he? Yeah, that's right. And I was like, we become quite specific, but one we like anyway. But walking along the beach in Bournemouth, I was like, they've got Converse, they've got us a Nike. And literally when I took the image, I remember going to the sketches, and yeah, and that's exactly what's done here. And you can see, because this one gives you a little bit more options around the brand, the models within that brand. It can be Arch Fit, it can be the Parademy or the slip-ins, but it liked the Arch Fit the most. And to be fair, this is the actual shoe from the website, so it's pretty. If we go move on to the other one, I think maybe the one of the crunchy ones I think you wrote down. I can't remember which one. The Snow one. Nike and Snow. I love Nike and Snow. This is our favourite one because it's a really clear one of the Nike and the Snow, and it comes up as Nike Air Force Ones. And if you drill through to the next page where we've got here, so you can see all around. So obviously, if you think about in a crime scene, they can flick through and see exactly what they're looking for. We added a little bit about information about it, but ideally, if you could enhance this with Gen AI, you could literally have some cases information, or this many crimes have been committed by these shoes in this location, maybe go and look at this dodgy person on the street, kind of thing. And then what we did is we also added in another predicted element of it, which was the measurements of the shoe. So we realized very quickly that there's a big difference between men's shoes and women's shoe size. So, but it can't tell you from the print which gender it is. So it just comes up with the measurements of the height and the width, and then you can use the sizing chart to work out if it's a male or a female, what size shoe you'd be looking for. So yeah, I think we can move to the code. No. I can see. We were talking about in the office, and one of the boys, they always ask really random questions when it comes to machine learning and data science stuff. And they said, "What does it think about the moon on the footprint on the moon?" And we were like, "Oh, okay, let's have a look." And it's quite funny because it just doesn't. I think it comes up as a Timberland. We train on that, so yeah, you can see the moon print. So that's where that comes from. Oh yeah, yeah, I did. Yes. It does like Timberland, but it's not confident enough because we basically allow the model to come through when the brand matched enough. Because it hasn't got a brand of over 70%, we said don't start predicting models for us because we're not confident with that number. So then it just comes up with the fish. So I will stop talking because I'm dehydrated and pass you this and this.
Okay, so now we're going to talk you through a little bit about how we created this demo. So as Karina's already mentioned, we're using the data science and machine learning elements of Microsoft Fabric. We've got OneLake where we're importing all of our data. We've got several notebooks that I'll talk you through in a minute that both train and predict the model of the shoe. And then we have our semantic model within Power BI and the Power BI dashboard sat on top of that. We've also got some tables that we've surfaced into the SQL endpoint, and these sit in the semantic model within Power BI. So first of all, I'm going to make sure my cluster's started because this is the bane of this demo. And it always takes a little while. So while that is starting up, I'll talk you through a little bit about the method that we've used to train this model. So first of all, we have to import all the modules that we've decided to use. You can see a couple of those in there. So we've got things like Hill, which is great for image processing. There were a lot of steps we had to take when we took the images off the internet before we could use them to train our demo. So it's really important to have that great data quality, else you're just not going to get the results that you want. We use something called MLflow, which is great for seeing how well you've trained each model. So within the experiment, you can see the different runs, and MLflow allows you to see certain metrics about it, such as the accuracy and the accuracy on the testing data set. So you can make changes to how you're training your model, and you can see how these are flowed through into the results. The model that we trained is a TensorFlow model. So you can see we've imported several things here, like different layers, and we've also imported some pre-trained models, which were fantastic for this use case. So the first step was, because we wanted to have all our Power BI tables in the semantic model, we create a load of tables for our predictions to go into from the machine learning model. And as it's a demo, we just drop and recreate these each time. I'm also going to run this, probably should run that, so that we've got all of our modules installed. So to train a machine learning model, what you need loads of images for each category. So the first step was to find a source for these images. The more you've got for each category, the more accurate that your model will be. So initially, we tried to stream these from the Nike website. Funnily enough, Nike does not let you do that. So we found several brands that would allow us to do this. So Vans, for example. But in the end, we had to go through and just source them manually. And you can see in my lake house here, I've got a folder for each of the brands that we trained it on. And in there, we've got all of our images stored. Just wait for that to process for a second while it installs all of those modules. So for each brand, we wanted to make sure we got a variety of images. The first issue we had was all of the Converse trainers. They were oriented differently to the other brands, so I think they were vertical and everything else was horizontal. So if I took a picture of the sole of my shoe and put it in a certain way, it thought it was a Converse based on that feature that it picked out. So one of the key things that we use the Hill module for is the pre-processing of the images. So we do things like random flips and rotations within the model that just accounts for that, takes out that element. Okay, so we've installed everything there. We've created all our tables, and then we've deleted from the SQL endpoint what was already in there. So here we have our image processing section. So what we're going to do now is we're going to train the model again and include a different brand within there. So we're going to include the Hunter's Wellington boot. So we've already uploaded to our lakehouse a load of files that we can use to train it on, and we're going to see if the moon boot comes up as anything different or not. So the first step that I need to do is to format all of my images. We do several things here. So if I just press that cell, so we convert them to RGB. We convert them all to PNG because you wouldn't believe the different number of image file types that you can find. And our TensorFlow model worked really well with PNG. So we decided to put a function in that just converted everything to PNG. We also normalize all of the images. So it makes all of the values of pixels like between 0 and 1, which just makes them all the same, all comparable, depending on like if one image was brighter than the other or something like that. It gets rid of the effect. See how that's carrying on? And just to bear in mind, this process is only if you want to retrain the model. We'll show you later on how you predict what type of shoe it is, and that's a much quicker process. So this is just every time you're adding in a new image, new brand, sorry. So that has pre-processed all of my images. So the next stage is to create a test and train data set. So in OneLake, I've got loads of images now. I want to split that data set into two parts. One that I'm going to use to train my machine learning model, and one that I'm going to test those results against to see how accurate it's been. So that's what this section does here. I split it out into features and labels. So the labels are like the categories, the brands of the shoe. So that has created my test data set that you can see here and my training data set. So what we've got here is the first version of the model that we created. So this uses a TensorFlow machine learning model. And we found surprisingly first time round with the limited number of images that we'd used that it wasn't very accurate. It could determine at a high level between the different types of brand, but if we wanted, for example, the difference between a Nike Dunk and a Nike Jordan, it couldn't do that level of detail. So what we decided to do was to use pre-trained models and then retrain just the top layers of that model specific to our data set. And this gave much more accurate results. So this example here is using the pre-trained model. I'll click on that there and then talk you through a little bit about what the code is doing. So here we use something called MLflow, which is great within Fabric for allowing you to monitor the progress of your experiments and the accuracy of your machine learning models. So you can change different values of parameters and you can see the effect that that's having on how well your model will perform. So here you can see I've named it Classify Shoes, and we'll have a look at that experiment later on. You'll be able to see all of the runs that we've done and the information that it gives you about those runs to help you choose which model you want to use as your production version. So you can see in here, we've got things like random flip, random rotation. So that's doing what I spoke about earlier. It's just creating a little bit more of a difference between all of the images in your data set and getting rid of features that we don't want the model to pick up on. And you can see in here as well where I've set the trainable layers to false for the base model. So this is where you're working with a pre-trained model and just training the top layers.
But you want to make this parameterized because it tells you how many brands we've added in. So we've actually make that 8 now because we've gone from 7 brands to 8 brands. You would want that parameterized so that you didn't have to remember to add that in because the amount of times we've got to add that in while demoing this, and otherwise it works.
I had to add it in yesterday because I was sure I'd forget today. So when you scroll down here, you can see the machine learning model being trained. So each epoch is like the number of times that the whole data set is being run through the model. So this is one of the things that you can vary between runs. So you don't want the model to be overtrained, so it picks up features that you don't really want it to learn. Say, for example, all Nikes are on a yellow background. If you train it too much on the training data set, it picks up really specific things about that data set that you don't really want it to learn. So one of the things we experimented with was how many times do we need it to run through? What are the best results for that? It does go rogue, yeah.
You train it too little, it doesn't really get it. Train it too much, it kind of starts trying to self-learn and goes a bit insane. So you have to find out the right balance in the middle.
So we're going to have a look at now what the experiment view looks like in Fabric. So if I click on here, it gives each run a random name, and you can see the metrics about that run. So you can see the accuracy. So it thinks this is 89% accurate, the loss and the loss value, and various other parameters about that run. So what I'm going to do is I'm going to save this run because we've just trained it on a new brand in there as well. and I'm going to select an existing machine learning model, which is a really nice feature. You can basically set your prediction notebook to just use the latest version of your model. So you save it, and then it will automatically pull through where you've used that elsewhere within your code.
It's also worth highlighting that it does, when you're training it becomes a bit of like a balancing act. Like I said, it can go a bit crazy, it can go a bit rogue, it can not train it very much. When you're trying to train it, you're trying to find that balance. You can go one too many or just a bit too far, and you're like, I don't have to go all the way back to the beginning. So you can actually pick any of these crazy names that it gives it. You can go back. You're like, actually, I've overtrained it now. I want to go back to where I was last time. You can overwrite the latest model with any of those. And this is why you can see where we've done it. We've gone through it a couple of times. You go down to the bottom, you'll see there's loads of red ones. Sorry, it didn't work. But you can actually, I really like to hear. This was our best results that we ever got. Let's go back and you can overwrite it. You don't have to retrain it. So it's it's basically an experiment. It's trial and error, but you can go back to a different point in time.
And you can set MLflow, the library within Python, to store whatever parameters it is that you need it to, and then they'll be pulled through into here as well. I just go back to my notebook. So what we've done there is we've trained it on this new brand. Now, we wanted our Power BI dashboard to predict the brand of the shoe and the model. So what we did is we said for certain shoes, like Vans, for example, all Vans shoes have the same sole. So there's no point trying to decide which model it is. But Nike Jordan, Nike Dunks, everything's different. So we wanted it to go down to that further level and say, I think there's a 50% chance that this shoe is a Nike Dunk, but I also think there's a 20% chance it could be a Nike Jordan. But we only wanted to do this if it was confident enough in the model it predicted. So we set it so that if it's 70% confident in the brand, it will then try and predict the model. So what we're doing here is we're then training it on the model. Yeah.
Well, you can't be lazy and hard.
I know. So we need to add the Wellington boot in here for it to work. I knew I shouldn't have deleted it. So last time we did this, we trained it on the Wellington boot. It's just like that, isn't it?
You look at the cut.
Wellington boots. So we've had to untrain it so that we can train it again for today. So this is basically creating a list of all of the image file paths that are stored within one lake and the brand and the model that they are, so that we didn't have to like put that list in. It just loops through all the files, because as it grew, we got lazy and we thought we don't want to just write these all in a CSV. So that's what that's doing there. Let's give that a second to finish. I'm going to blame it on the Wi-Fi.
Yeah, Fabric has had some problems today.
Yeah.
All the team chat were going off, and they're like, "Does anyone know anything about Fabric?" We're like, "Please come back to life! Please come back to life!"
Okay, it has worked for us. So again, we're going to create our test and train data sets for the model level now. So that's doing the same process we spoke about before with the features and the labels, splitting it into a test and train data set. And then again, we're going to train it using our pre-trained model that has then had the top layers retrained specific on our data set. And then hopefully I'm going to run the prediction notebook and you'll be able to see the new brand has been added into Power BI. But that is only if the live demo gods are kind to us. So please bear with me on that one. Again, if you scroll down here, you can see it progressing through your data set. So you know that it is actually working, which is quite nice. And then for each line, you've got the accuracy for that particular run. So it starts off fairly low. It's done all right on the first time this time, to be honest, I think of 70%. But each run through the data set should get more accurate. If it's getting less accurate, that's when you started to overtrain it and you want to go in and reduce the number of times that it's running through, and then hopefully you'll get a better result. So here you can see I've set it to run through 7 times. So these are the kind of things you can just change about and see how the results change based on what you've put in there. Do we think this is going to have worked?
Yeah, exactly. I was just trying to remember the number.
So again, once this is run, I'll go into the model run and save the new version. Yeah, so we go in there. Now this is where Fabric can mess with you sometimes. Like that's not the newest version, that's the one that we saved for the brand. So I'm going to go back again. So we want Frosty map. Otherwise, it's something different. I might just have to refresh this view. Yeah, it's ready to go home for the day. Okay, so now we can see we've got Frosty map in there. So I'm going to save this new run as my latest version. And this time it's our model of shoe. Okay. So then what we've got is we have a separate notebook that you would run if you want to predict what type of shoe it is. So you go into the Lakehouse and within the predict folder, you upload the images that you wanted to predict. So you can see we've got those ones that we showed you earlier, the different crime scenes and the audience shoe from previous demo in there. So these are the shoes that it's going to use to predict, and you'll be able to see in Power BI. Fabric's being really kind and disconnected my session, so I'm going to just start that up again. It has been having some problems today, so hopefully it will pull through. No, this one's quite quick to run. Yeah. So we've got our modules that we're installing again. And then we just delete out the predictions from last time, just with it being a demo. We haven't merged it in or anything like that. We just clean it all out, start from scratch. And these are the tables that you'll be able to access in the SQL endpoint, and they're the ones that pull through into Power BI. So we've got our brand prediction, our model prediction, and then we have like the file path of the image, which is what you can select at the top to choose. We then use the machine learning model to predict the brand and the model of the shoe. So it's a TensorFlow model that we've trained. So this converts the input image into a tensor of the right size and shape so that it can be used with the model. Also, it converts it to RGB, things like that, and resizes them. And then the important bit is that it references our latest version of the model. So you can see in this line here, we use MLflow again to refer to the latest version of our brand model. And that is what it runs. And if the probability is greater than 70%, it will then run the model prediction and try and tell which type of night trainer it is, for example. I might reload this. I think it's crashed. TensorFlow. So I always find it hard to say. I think it's a convolutional neural network machine learning model training method. So it converts everything to tensors, which is like a matrix. Hard question is, I think it's a matrix where each element is a vector, but I'm happy to be told I'm wrong on that. I've just gone with it worked for this purpose. No one's shouted up and down that that's wrong, so we'll go with that for now. Okay, I think that has loaded now, so hopefully it's going to let me run this. If not, we won't worry about that, and we might talk through some of the other possible use cases of this kind of machine learning model and any other questions. Is it running? Perfect. It's just a little slow today. No, that's a whole different conversation. I don't think we've got time for that one today. So once these are installed, it'll be fairly quick. This is the bit that just takes a little bit of time at the start. Is that better? Is that back? Brilliant. Okay, so we delete out all our old predictions. Definitely decided to go slow on everything. It probably does a little bit, but it still worked with the ones that we'd gone for. To be honest, it was one of those things where I tried it that way and it still predicted it correctly. So we didn't question it too much, but yeah, I think it probably does have an impact, and that there's probably a better way around it than the one I took. Yeah, go for it. Yeah, definitely. Some are better than others. Yeah. So if you look in here, there's like ResNet and 50. I tried it with all of these and just went with the one that worked best for this case. So they're all pre-trained on other things. And it tends to be a wide range of just objects in general.
And it's better now. Microsoft have got like a big whole selection of folders where they really worked on it, especially when they moved into the Gen AI sort of world as well. So if you go there, it's way better than what we had when we built this over a year ago. It's like way more of them. There's some that are built. I think they've even got one for like language interpretation.
Yeah.
So they've got like a machine learning model that right now, if half people spoke Spanish in the room, it would speak English and speak Spanish at the same time. And they've got loads of more of them now. It's really best on what they've done.
Is it AI Foundry where they all are? Have they changed the name? Don't know.
Well, that's a good question.
Okay, so we can see that it's running now. So each time that it runs one of our models, you can see that it does this here in the little progress bar. So that's how you know that it's done in both of those. And it has succeeded. So hopefully I'm going to refresh this and we'll have a new model in here. But being as I've had to run things a couple of times, it might not have. Let me just refresh. Yeah, so you can see in there we've got our new model of Hunter's boots in there. So we can try the moon boot again. My mic just gone off. Yes. I can tell now. Just about. Is that better? Yeah. Perfect. So if we try the moon boot. That's the filters in Power BI. So it only works when we've selected one one at the top here, so it's just summing it all up for the rest of the time. So it still thinks it's a Timberland today, but that's the thing with the model. Every time you train it, it gives you slightly different results. When we trained it in Stockholm, it then thought this was a Wellington boot. So there's features it's picking up from each, and today it thinks it's a Timberland. Yeah, it does. Microphone thinks it's time to go home, but